Alright, so we're going to be converting complex numbers from polar form into rectangular form, and the general steps are to basically find the real part using the equation x is equal to r cos theta, and the imaginary part using y is equal to r sine theta, and once you have those two values, you can just put them into the rectangular form here.
So we have one CIS of 0. So we put that in form, which is z is equal to 1 CIS of 0. And if we expand that, it becomes 1 times cosine of 0 plus 1I sine of 0. And that would mean that x is equal to 1 cosine of 0. And y is actually is equal to 1 sine of 0. And so x is equal to, x's equation is equal to 1 times 1. And y's equation is equal to 1 times 0. So x is equal to 1 and y is equal to 0, which would mean that putting it back into form, we have z is equal to 1 plus I times 0, which is just z equals 1. So we have 2 CIS of pi over 2, and when we put it in form, z is equal to 2 CIS of pi over 2. And that becomes 2 times cosine of pi over 2 plus 2 times I sine of pi over 2. So x is equal to 2 times cosine of pi over 2, and y becomes 2 times sine of pi over 2. So x is equal to 2 times 0, and y is equal to 2 times 1. So x becomes 0, and y is equal to 2. Putting that back into form, we have z is equal to 0 plus 2i. And that would just mean that z is equal to 2i.
Alright, for this one, we're gonna find the real component. And so x is equal to 5 cosine of pi, which is going to be equal to 5 times cosine of pi is going to be -1, and that's going to give you -5. For our imaginary part, we'll have y is equal to 5 sine theta, sine pi, which is going to be equal to 5 times 0, since sine of pi is 0. That's going to give you 0. And so we can write this complex number as -5 plus 0i, which is basically just equal to -5. Right, for this one, we're going to solve for the real part. And so that's going to be 2 times the cosine of 3 pi over 2, which is equal to 2 times 0, which is equal to 0. For imaginary part, y is going to be equal to 2 times the sine of 3 pi over 2, which is equal to 2 times -1, which is equal to -2, and therefore we can write this complex number as 0 minus 2i, which is just equal to -2i. For this question, we do the same thing. Our x is going to be equal to 3 times the cosine of pi over 4, which is equal to 3 times square root of 2 over 2, since cosine of pi over 4 is square root of 2 over 2. That will give us 3 square root of 2 all over 2. For our imaginary part, we have y is equal to 3 times sine of pi over 4, which is equal to 3 times square root of 2 over 2, since sine of pi over 4 is also square root of 2 over 2. That will also give us 3 square root of 2 all over 2. And therefore, this complex number will be written as 3 square root of 2 over 2 plus 3 square root of 2 over 2i.
Have 6 CIS of pi over 3, and putting that into form is z is equal to 6 CIS of pi over 3. And when we expand that, that becomes 6 cosine of pi over 3 plus 6i sine of pi over 3. And that would mean that x is equal to 6 times cosine of pi over 3. And y is equal to 6 times sine of pi over 3. So x becomes 6 times 1 over 2. And y becomes 6 times square root of 3 over 2. And so x is equal to 3, and y is equal to 3 square root of 3. So when we put it back into the equation, it would become z is equal to 3 plus 3 times square root of 3i.
For this one, we have x is going to equal 5 times the cosine of 2 pi over 3. This is going to be equal to 5 times cosine of 2 pi over 3 is going to be negative 1 over 2. So that evaluates to negative 5 over 2. For our imaginary part, we have y is equal to 5 times the sine of 2 pi over 3, which is equal to 5 times sine of 2 pi over 3 is going to be square root of 3 over 2, and therefore this is 5 square root of 3 over 2. And we can write this complex number as negative 5 over 2 plus 5 square root of 3 over 2 times I. For this question, our real part, x is going to be equal to 2 times the cosine of 5 pi over 6, which is equal to 2 times the cosine of 5 pi over 6 is negative square root of 3 over 2, and the 2's will cancel, so this will evaluate to negative square root of 3. For our imaginary part, y is equal to 2 times sine of 5 pi over 6, which is equal to 2 times sine of 5 pi over 6 is 1 over 2. So this is going to be equal to 1 since the 2's will cancel out. Therefore, we can write this complex number as negative square root of 3 plus 1i, which is just equal to negative square root of 3 plus I. For this question, our real part x is going to be equal to 3 times the cosine of 7 pi over 6. This is equal to 3 times cosine of 7 pi over 6 is equal to negative square root of 3 over 2. And this will give us negative 3 square root of 3 over 2. For our imaginary part, y is equal to 3 times the sine of 7 pi over 6. That's equal to 3 times sine of 7 pi over 6 is negative 1 over 2. That evaluates to negative 3 over 2, and therefore we can write this complex number as negative 3 square root of 3 all over 2 minus 3 over 2i. For this question, our real part x is equal to 9 times the cosine of 4 pi over 3, and this is equal to 9 times cosine of 4 pi over 3 is negative 1 over 2, and that evaluates to negative 9 over 2. For our imaginary part, y is equal to 9 times sine of 4 pi over 3. This is equal to 9 times The sine of 4 pi over 3 is negative square root of 3 over 2, and that evaluates to negative 9 square root of 3 over 2. Therefore, we can write this as negative 9 over 2 minus 9 square root of 3 over 2i. For this question, our real part x is going to be equal to 11 times the cosine of 5 pi over 3. This is equal to 11 times the cosine of 5 pi over 3 is going to be 1 over 2. And this evaluates to 11 over 2. For our imaginary part, y is equal to 11 times the sine of 5 pi over 3. That's going to be 11 times negative square root of 3 over 2, which is going to give us negative 11 square root of 3 over 2. Therefore, we can write this as 11 over 2 minus 11 square root of 3 all over 2 times I. For this question, our real part x is going to be equal to 2 times the cosine of 11 pi over 6, which is equal to 2 times the cosine of 11 pi over 6 is square root of 3 over 2. The 2's will cancel out, leaving us with the square root of 3. Our imaginary part y is going to be equal to 2 times sine of 11 pi over 6, which is going to be equal to 2 times the sine of 11 pi over 6 is negative 1 over 2. The 2's will cancel out, leaving us with negative 1. And therefore, we can write this as square root of 3 minus I. For this question, our real part x is going to be equal to 8 times cosine of pi over 4, which is equal to 8 times the square root of 2 over 2. 8 divided by 2 is 4, so that leaves us with 4 square root of 2. Okay, for our imaginary part, y is going to be equal to 8 times the sine of pi over 4, which is equal to 8 times sine of pi over 4 is square root of 2 over 2. 8 divided by 2 is 4, and so this also evaluates to 4 square root of 2. And therefore, we can write this complex number as 4 square root of 2 plus 4 square root of 2i.
And putting that in the equation is z is equal to CIS, 10 CIS, 3 pi over 4. And expanding that would be 10 cosine of 3 pi over 4 plus 10 I sine of 3 pi over 4. X would be equal to 10 cosine of 3 pi over 4. And y would be 10 sine of 3 pi over 4. So x is equal to 10 times negative square root 2 over 2. And y is equal to 10 times square root of 2 over 2. And so x becomes negative 5 times the square root of 2. And y becomes 5 times the square root of 2. And so the the final equation becomes z is equal to negative 5 square root of 2 plus 5 square root of 2i.
For this question, x is going to be equal to 16 times the cosine of 5 pi over 4, which is equal to 16, and the cosine of 5 pi over 4 is negative square root of 2 over 2. 16 divided by 2 is equal to 8, so we get negative 8 square root of 2. For our imaginary part, y is equal to 16 times the sine of 5 pi over 4. That's equal to 16 times negative square root of 2 over 2, which is equal to negative 8 square root of 2, and therefore we get negative 8 square root of 2 minus 8 square root of 2 times I. For this question, our real part x is going to be equal to 15 times the cosine of 7 pi over 4, which is equal to 15 times square root of 2 over 2, which is equal to 15 times square root of 2 over 2. For imaginary part, y is equal to 15 times the sine of 7 pi over 4, which is equal to 15 times sine of 7 pi over 4 is negative square root of 2 over 2, and we get this. And therefore, we can write this number as 15 times square root of 2 over 2 minus 15 square root of 2 over 2i. For this question, we see that the angle is 5 pi over 12, which is not one of the common angles that you're going to remember. And so we are going to make use of the sine and cosine addition identities in order to find the exact value for the trigonometric functions. And so the first thing we need to realize is that 5 pi over 12 is equal to pi over 4 plus pi over 6. Because we have pi over 4, which is equal to 3 pi over 12, and then add pi over 6, which is 2 pi over 12, and that gives us 5 pi over 12. And therefore, when we want to find our real part, which is going to be equal to 9 times the cosine of 5 pi over 12, we can rewrite this as 9 times the cosine of pi over 4 plus pi over 6. After that, we can make use of the cosine addition formula, which is going to be cosine of pi over 4 times cosine of pi over 6. Make sure to put the 9 in front. And then subtract sine of pi over 4 and sine of pi over 6. This is equal to 9 times cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Subtract sine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1 over 2. And so this evaluates to 9 times. This is square root of 6 over 4, and subtract square root of 2 over 4. Okay, now we need to find the imaginary part, and so we want y, which is going to be equal to 9 times the sine of 5 pi over 12, and we can basically do the same thing that we did for x, which is we replace 5 pi over 12 with pi over 4 plus pi over 6. This time we will use the sine angle addition formula, which gives us 9 times sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 times the sine of pi over 6. This is equal to 9 times sine of pi over 4, which is square root of 2 over 2, cosine of pi over 6, which is square root of 3 over 2, and then add cosine of pi over 4, which is square root of 2 over 2, sine of pi over 6, which is 1 over 2. This evaluates to 9 times. This is square root of 6 over 4, and these two parentheses here are square root of 2 over 4. And so we have everything we need. We can finally write this as 9 times the square root of 6 minus square root of 2 over 4. That's going to be the real part. And then for imaginary part, we have 9 times square root of 6 plus square root of 2 over 4 times I. Okay, for this question, our real part, x is equal to 16 times the cosine of 7 pi over 4, which is equal to 16 times square root of 2 over 2, which is equal to 8 square root of 2. For our y, we have y is equal to 16 times the sine of 7 pi over 4, which is equal to 16 times negative square root of 2 over 2, which gives us negative 8 square root of 2. And therefore, we get 8 square root of 2 minus 8 square root of 2 times I.
Alright, so we have z is equal to 1 CIS of 13 pi over 12. And that expands out to 1 times cosine of 13 pi over 12 plus 1 times I times sine of 13 pi over 12. And that would mean that x is equal to 1 times cosine of 13 pi over 12. And y would be equal to sine of 13 pi, well, 1 times sine of 13 pi over 12. So to calculate cosine of 13 pi over 12 and sine 13 pi over 12, we have to split the angle out into 2 parts, and that would mean that we could do pi over 4 and 5 pi over 6. So when we add that up, that would be equal to 13 pi over 12. And so that would mean that x is equal to 1 times cosine of pi over 4 plus 5 pi over 6. And so when we expand that out, that would be equal to 1 times cosine of pi over 4 times cosine of 5 pi over 6 minus sine of pi over 4 and cosine of 5 pi over 6. Sine of 5 pi over 6. And simplifying that would give us 1 times square root 2 over 2 and negative square root of 3 over 2 minus square root 2 over 2 and multiply up times 1 over 2. And that would equal to 1 times square root of 6, negative square root of 6 over 4 minus square root of 2 over 4. And that finally gives us negative square root 6 minus, well, we could put it into one entire fraction. And so negative square root of 6 minus square root of 2 all over 4. Alright, so y is equal to 1 times sine of 13 pi over 12. And so we now make the equation. We need to split that into the 2 angles, which is 1 times sine of pi over 4 plus 5 pi over 6. So when we expand that, it would be equal to 1 times sine of pi over 4 times the cosine of 5 pi over 6 plus the sine of 5 pi over 6 times cosine of pi over 4 And that would be equal to 1 times square root 2 over 2 times negative square root 3 over 2 plus sine, my bad, 1 over 2 times square root 2 over 2. So that would compute out to be 1 times negative square root 6 over 2. 4. 4, yeah. Plus square root 2 over 4. Okay. So that would just become negative square root 6 plus square root 2 over 4. So finally, when we're putting it in form, that would be z is equal to negative square root of 6 minus square root of 2 over 4 plus negative square root of 6 plus square root of 2 over 4 times I.
Okay, for this question, we see that this angle is also not one of the common ones, and so we're going to break this down into the sum of two more common angles. So 19 pi over 12, that is equal to 4 pi over 3 plus pi over 4, because 4 pi over 3 is 16 pi over 12, and pi over 4 is 3 pi over 12. So when we're trying to find the real part, our x is going to be equal to 4 times the cosine of 19 pi over 12. And this is going to be equal to 4 times cosine of 4 pi over 3 plus pi over 4. And so we can use the cosine angle addition formula. Here we can rewrite this as 4 times cosine of 4 pi over 3 times cosine of pi over 4 subtracted by sine of 4 pi over 3 times sine of pi over 4. That's equal to cosine of 4 pi over 3 is negative 1 over 2. Cosine of pi over 4 is square root of 2 over 2. Sine of 4 pi over 3 is negative square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. And so this equals 4 times, this just becomes negative square root of 2 over 4. This becomes positive square root of 6 over 4. And so we get 4 times square root of 6 minus square root of 2 over 4. And the 4's cancel out, leaving us with just square root of 6 minus square root of 2. Okay, for our imaginary part, y is going to be equal to 4 times the sine of 19 pi over 12, which is equal to 4 times the sine of 4 pi over 3 plus pi over 4. You can use the sine angle addition formula here. This is equal to 4 times sine of 4 pi over 3 times the cosine of pi over 4 plus the cosine of 4 pi over 3 times the sine of pi over 4. That's equal to 4 times sine of 4 pi over 3 is negative square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. And then we're going to add cosine of 4 pi over 3 is negative 1 over 2, and sine of pi over 4 is square root of 2 over 2. This is equal to, it's just negative square root of 6 over 4, and then subtracted square root of 2 over 4. This is equal to 4 times negative square root of 6 minus square root of 2 all over 4. The 4's will cancel out, leaving us with negative square root of 6 minus square root of 2. Therefore, we have everything we need. We can write this complex number as square root of 6 minus square root of 2. And then our imaginary part, negative square root of 6 minus square root of 2 times I. We can simplify this a little bit. We can pull the negative out of this parenthesis here. So this just becomes a subtraction, and we get square root of 6 plus square root of 2 times I. For this one, we have x is equal to 16 times the cosine of 2 pi over 3, which is equal to 16 times negative 1 over 2, which is equal to negative 8. For imaginary part, y is equal to 16 times the sine of 2 pi over 3, which is equal to 16 times square root of 3 over 2, which is equal to 8 square root of 3, and therefore we can write this complex number as negative 8 plus 8 square root of 3 times I. For this question, our x is going to be equal to 13 times the cosine of 5 pi over 3, which is equal to 13 times 1 over 2, which is equal to 13 over 2. Our imaginary part y is going to be equal to 13 times the sine of 5 pi over 3, which is equal to 13 times negative square root of 3 over 2, which is equal to negative 13 square root of 3 over 2. Therefore, we can write this as 13 over 2 minus 13 square root of 3 all over 2 times I. For this question, our real part, x is going to be equal to 38 cosine of pi over 4, which is equal to 38 times the square root of 2 over 2, which gives us 19 square root of 2. For our imaginary part, y is equal to 38 times the sine of pi over 4, which is equal to 38 times square root of 2 over 2, is equal to 19 times square root of 2. Therefore, we can write this as 19 times square root of 2 plus 19 square root of 2 times I. Alright, that's it for this video. I hope to help. Thanks for watching.